There's no real difference in terms of the basic genetic material that goes into a human in terms of bread or biscuit or for animals, whether it be a pig or a chicken. The difference is that we have different nutritional requirements. Chickens don't actually eat bread.
I mean, traditionally wheat has been bred with the biscuit baker market in mind, and most of the research work and development work and breeding work was geared towards those two main end users. Whereas the animal feed sector is perhaps the major user of wheat in this country. We probably allocate about, 5 million tonnes of homegrown wheat goes down the throats of pigs and chickens. So we are the biggest end user. So the change that's taken place in the last 10 years or so has been a realisation by both the plant breeders and by the wheat molecular biologists that we ought to consider rather more the pigs and the chickens that consume the wheat.
The market's evolving. It has to evolve as we're finding new uses for wheat. And perhaps the two best examples are the export market, where a lot of our grain now goes into Portugal, into Spain, into Italy. They're soft milling varieties built on the back of the wonderful climate that we have for growing those type of varieties. But we're now starting to see an embryonic biofuels industry, and they'll have different demands. So we're really seeing a big change taking place. We've seen one in terms of the export market, and I think we're going to see a change in the next few years as the market becomes more competitive for grain, particularly in the north of the country where these biofuel industries are establishing big plants.
What we're doing in terms of wheat for animal feed purposes is trying to examine which genes will make wheat better adapted for feeding to pigs and chickens in particular. As you know, about 40% of the wheat market goes into animal feed and animal feed compounding, but it's probably the least studied of the end uses of wheat, and consequently, how can we translate the genetic information in particular that we've learned from studying bread making quality, biscuit quality, into producing a wheat that has higher nutritional value, particularly in terms of digestibility for the animal feed sector?
We're starting to see that there are significant benefits to be had in terms of both the animal performance, but also in terms of things like the impact that it would have on the environment, the waste product that comes from the animal production system. Inevitably, animals are taking nutrients in through the feed, but they're also excreting nutrients out. And what we're also trying to do is to look to minimise that level of excretion, be it nitrogen or phosphorus or any of the key environmental impact nutrients. So we've seen significant improvements in that area as well. So it's almost a win-win situation. We're getting better animal growth, but we're also having a reduced impact on the environment.
Well, we're looking at quality of the end product. So what influences quality as far as the pig and the chicken is concerned is now becoming a dominant feature of their breeding policies. And that's been a subtle change over the last 10 years or so. And you can perhaps think of one example of this. There's called the 1B, 1R rye translocation, which is quite a mouthful, but it was introduced into the wheat genome many years ago to boost yield. And everyone was very happy with this, but the problem was that this particular 1B, 1R translocation lowered nutritional value. So we had wheat being produced by farmers, which was of lower nutritional value because of this breeding policy. So that's now been stopped, certainly in the UK. That's perhaps a major outcome, if you like, thus far, of work that we're doing here at Nottingham.
And why is it that Nickerson, as a plant breeder, has decided to, perhaps independently, look at this particular market as opposed to looking specifically at the human market?
Within our business, we're looking not 3 years down the line, 5 years down the line, 10 years down the line, 20 years down the line. We are looking very long term, and we see that there will always be a need for nutrition for animal feed.
Well, one of the things that we focused on, which early in our studies seemed to be something that was important, was grain texture. We know that there's a single major gene that determines the difference between hard and soft texture, but within those categories, we found that there was actually more to it than that, and that you can get a range of textures from soft softs to hard softs to soft hard to hard grain type varieties. And what we've done recently is dissect that texture. From studies in the United States, we now know the genetic sequence of the gene that determines the major difference in textures. And so we're finding that probably soft varieties have greater digestibility than hard varieties. And this probably ties in with some other information that it seems from studies that I understand anyway, that soft varieties are better for bioethanol production.
Biotechnology presents us with an even greater opportunity to short-circuit that timescale. The trouble with plant breeding or wheat breeding is that it's an 8 or 10-year cycle to go from crossing a variety to actually getting a variety into the marketplace. We have now technologies available to us, things like double haploid technology, which will allow us to speed programs up. We've also got access to molecular markers that gives us, if you like, tags on traits of high value. So once we've identified a high value trait, we will be able to progress that through the program without fear of losing it. So that really is, those technologies together can give us a real springboard. Perhaps in the past, when looking at bread-making varieties, we're looking at a 40 or 50-year cycle. Using these technologies, we can make it a lot quicker with this particular sector.
Genetics is moving quite quickly within wheat, and generally we see the advances that are being made in the human genome and sequencing and understanding genes. Well, now we're getting the tools to do exactly this in wheat. So our understanding of genes is increasing greatly our understanding of the genes that the plant breeders are handling. So we're now doing things routinely using, for example, a technique called marker-assisted selection, which we didn't do 5 years ago. So technology is moving along quite quickly and will accelerate into the future.
What farmers want to do is that they want to produce something that they can sell. It's as simple as that. What we need to do as UK PLC is to produce something that is desirable in our internal market and desirable in the export market. I think growers get frustrated in a way that they just grow hard feed wheats and they are at the mercy of the market in terms of price. I think what they really want to do is, and the farmers that I've dealt with are all very keen to know that they've produced something that is going into a particular process or whatever. So I think that the win from their point of view is actually be able to define exactly what this very big sector of the industry wants. The other benefits that have got to come are in terms of us integrating that end-use requirement with better disease resistance, agronomic traits, insect resistance. We've got to put all the building blocks together, and at the moment what we tend to do is we tend to do it a little bit piecemeal. And I think that what we've got to do is to join up all of that, and then I think the farmer will get a real benefit. And of course the industry may find itself in a position rather like the bread industry, where it may find individual varieties that have an additional and higher value, which will give them value, and perhaps we can build some small premiums in for growers as well.